Hello students, welcome to lecture series of Mathematics 2. I, Tina Joshi from Mathematics Department, Acropolis Institute of Technology and Research welcomes you all once again in the video lecture series of Mathematics 2. Today we will going to discuss the topic from module 4th of M2 and the topic is Cauchy's integral theorem and Cauchy's integral formula. Cauchy's integral theorem, also known as Cauchy's theorem. So first we will discuss about the Cauchy's integral theorem or Cauchy's theorem. Here's the statement, and the statement is if f of z is an analytic function and its derivative, that is f of dash z, is continuous at each point within and on simple closed curve C, then integration along C f of z dz equals to 0. So simple closed curve, that is also we can say it is a closed curve or contour C. So the function f of z is analytic within, that is we are talking about within, that is inside the curve. Okay, and on by we mean that we are talking about the boundary of that curve. Then with respect to that curve, if we denote the integral of f of z, the value we will get is 0. So for example, if I am having f of z equals to 1 upon z minus 2 with unit circle mod z equals to 1. Okay, mod z equals to 1. So mod z equals to 1, that is it is a circle, the center is origin and radius 1. So for that solution, what you need to do, first you need to check the singularity of that function. For the singularity, just put the denominator part or equate the denominator part equal to 0. Put z minus 2 equal to 0, that is z equals to 2. Z equals to 2 is the singular point. Z equals to 2 is the singular point, that is it is the point where the function is not analytic. Okay, that is if we put z equals to 2 over here, we will get infinity, 1 by 0, that is infinity, that is function is not defined at z equals to 2. So what you need to do next, that is mod z equals to mod 2, which is 2, and 2 is greater than 1. Why we are checking it 1? Because it is given unit circle mod z equals to 1. So 2 greater than 1, that this point 2 lies outside C. So according to Cauchy's integral theorem, the value of the integral will be 0. That is value of the integral, that is dz upon my z minus 2 is equals to 0. So in a simple way, for the Cauchy's, what is Cauchy's theorem saying? If f of z is analytic within, that is inside and on the simple curve C, and there is a point A whose singularity is outside the curve, then the value of the integral over C will be 0. Okay, so this is the Cauchy's integral theorem. Next we will move to Cauchy's integral formula. So here is the Cauchy's integral formula, and the statement for the Cauchy's integral formula is if f of z is analytic within and on closed curve C and there is a point A within C which lies inside C, then f of a equals to 1 upon 2 pi iota integration along C f of z upon z minus a dz. Okay, so Cauchy integral theorem is saying that if the singularity of function is outside the curve, then the value of that integral will be 0. But Cauchy integral formula is saying that the function is analytic inside and on the curve C, but there is a point A which lies inside C, then we can find the value of that point by the formula 1 upon 2 pi iota integration along C f of z upon z minus a dz. We can also evaluate the integral with the help of Cauchy's integral formula, as 2 pi iota comes over here with f of a, then here the remains is integral. So we can also evaluate the integral with the help of Cauchy's integral formula. Okay, now there is a deduction part for the Cauchy's integral formula. If f of a equals to 1 upon 2 pi iota integration along C f of z upon z minus a dz, and we differentiate this one with respect to a, then what we get? F of E differentiation will be f of dash a, and when we differentiate with respect to a, we have z minus a inverse dz, that is, it is what is equals to 1 upon 2 pi iota integration along C, it is f of z minus 1 z minus e to the power minus 2 and dz, that we will get what? We will get this one, 1 upon 2 pi iota integration along C f of z z minus a ka whole square and dz. Similarly, if we find the second derivative, similarly we will get this one. Okay, and if similarly we can write third derivative, what will be f triple dash a equals to 2 factorial, now it will be 3 factorial, 2 pi iota integration along C, and here it is f of z, and in the denominator one power will be increased, that is z minus a to the power 4 dz. Okay, so in general for the derivative part we can write f to the power n equals to n factorial upon 2 pi I integration along C f of z upon z minus a to the power n plus 1 dz. So let this one will be the equation first. This is the Cauchy's integral formula to find the value of the function at the point A. Okay, and the second, third, fourth are the derivative formula for the Cauchy's integral. So what you need to do, if in the given integral, here it is z minus a, that is power is 1, so simply apply the equation first, Cauchy's integral formula, and if the power is greater than 1, that is here z minus a square, z minus a whole cube, z minus a to the power 4, or in general z minus a to the power n plus 1, you can simply apply the derivative formula for Cauchy's. Okay. So let us understand more clearly with the help of example. So here it is the example. The integral is, you need to evaluate e to the power 2z upon z plus 1 to the power 4 dz, where c is the circle mod z equals to 3. So by derivative formula, of Cauchy's integral. Why we are using derivative formula? Because in the given integral which is need to be evaluated, here it is z plus 1 to the power 4. Okay, so what is the derivative formula? F to the power n a equals to n factorial, and in the denominator it is 2 pi iota integration along C f of z upon z minus a to the power n plus 1 dz. Okay, and our integral is e to the power 2z upon z plus 1 to the power 4 dz. So we can write it as e to the power 2z upon z plus 1 to the power 3 plus 1 dz. Okay. So when we compare this one, so here when we compare, so f of z, that is e to the power 2z, so therefore here f of z equals to e to the power 2z, and here it is z plus 1, that is z minus a, so e equals to minus of 1, and here n plus 1, that is 3 plus 1, so n equals to 3. Okay, also you need to check the singularity first. So before that, let this one be the equation number first. So from first, what we have, put all the required values over here. So f of n, that is 3, that is here triple dash a, that is minus of 1, n factorial, that is 3 factorial, and in the denominator it is 2 pi iota integration along C f of z, that is e to the power 2z, and in the denominator it is z plus 1 to the power 4 and dz. So what you need to do, you need to find simply the value of integral. So for the value of integral, what this 2 pi iota will come over here and factorial 3 is here. It is f triple dash minus of 1 equals to integration along c e to the power 2z and in the denominator z plus 1 to the power 4 dz. Okay. So let this equation number second. Okay. So here for the singular point, what you need to do now, equate the denominator part, where the value will be z plus 1 equal to 0, that is z equals to minus of 1 or z equals to a equals to minus of 1. Now mod z equals to mod a, that is minus of 1 equals to 1, which is less than 3 because it is given to evaluate the integral with mod z equals to 3. Therefore, we are checking with 3. So 1 is less than 3, therefore it lies inside C. If less than, it is lies inside C. If greater than, outside C. And if equal, then on the boundary. So now then what you have to do for the equation first, just you need to find the value of third derivative at point minus of 1. So here f of z is e to the power 2z. Differentiate it 3 times. F of dash z, that is 2 e to the power 2z. F of double dash z, that is 4 e to the power 2z. And its third derivative, that is f of triple dash z equals to 8 e to the power 2z. And now we find it at point a equals to minus of 1, that is z equals to a equals to minus of 1. So basically here it is 8 e to the power minus of 2. So just put this value simply in equation number second. Then from second 2 pi iota 3 factorial, that is 6, f of triple dash, that is 8 e to the power minus of 2 equals to the integral which is given to evaluate, that is z plus 1 4 to the power 4 is dz. Okay, just simplify it. So the answer is integration along c e to the power 2z and in the denominator z plus 1 to the power 4 dz equals to what? It is 8 by 3 pi iota e to the power minus of 2. That is the answer. Okay. So in this way we can apply the Cauchy's integral derivative formula. So let us take another example. So using Cauchy's integral formula, we need to evaluate integration along C 4 minus 3z upon z minus 1 z minus 2 dz, where C is the circle, mod z equals to 3 by 2. Okay. So here the power is 1. So we use the simply Cauchy integral formula. So by Cauchy integral formula, we have f of a equals to 1 upon 2 pi iota integration along c f of z upon z minus a and dz. Okay. Or as we need to find the value of integral, it is integration along c f of z upon z minus a dz equals to 2 pi iota into f of a. Right? So first we are having integration along c 4 minus 3z, z minus 1 and z minus 2 dz. So what you need to do first, check the singularity. Okay. So for singular points, put z, z minus 1, z minus 2 equal to 0. This implies z equal to 0, z minus 1 equal to 0, that is z equals to 1, and z minus 2 equal to 0, that is z equals to 2. Okay, so points are z equals to a equals to what? It is 0, 1 and 2, right? So first you need to check what is given. Mod z equals to 3 by 2. It is given mod z equals to 3 by 2. So first you need to check it lies inside or outside. So let this will be equation number first. So at z equals to a equals to mod 0, that is 0 which is less than 3 by 2. So this point lie inside C. Okay. Next one is mod z equals to mod 1 equals to 1, which is again less than 3 by 2. It also lies inside the curve C. Similarly, mod z equals to mod 2 equals to 2, which is greater than 3 by 2. So it is lie outside the C. Okay. Now our integral is 4 minus 3z, and in the denominator it is z minus 1, z minus 1, z minus 2 dz. So by first we need to separate it by using partial fraction. So what you have to do, it is simply by using partial fraction. First we need to simplify it by using partial fraction. 4 minus 3z upon z, z minus 1, z minus 2, or it is a by z, b by z minus 1 plus c by z minus 2, and we have to simplify, that is 4 minus 3z equals to a z minus 1 z minus 2 plus b z z minus 2 plus c, here it is z and z minus 1. Okay, so we need to find the value of ABC first. So here it is, put z equal to 0, then we will get 4 equals to a minus 1 and minus of 2, that is a equals to 2. Okay, again put z equals to 1, where we are putting in that part. Okay, in that equation, whole equation. So here it is 4 minus 3, that is we are having 1. Okay, so here it is 1 equals to b1, and here minus of 1, so b equals to minus of 1. Similarly, put z equals to 2, then we are having, put z equals to 2, we are having 4 minus 6 equals to c 2, and it is 2 minus 1, that is we are having value of c equals to minus of 1, right? So put value of ABC over here. So what we are having finally, that is then 4 minus 3z upon z, z minus 1, z minus 2 equals to a, that is 2 upon z, b and c are minus 1, that is z minus 1, and 1 upon z minus 2. So we need to evaluate the integral. Okay, so what we, that is integration along c, 4 minus 3z upon z, z minus 1, z minus 2 dz equals to what? To integration of 1 by z dz minus integration 1 upon z minus 1 dz minus integration 1 upon z minus 2 dz. Okay, but in that we do not need to evaluate that integral, because z equals to 2 point lies outside C, and according to Cauchy's integral theorem, if the point is outside C, then the value of that integral over that curve will be 0. So here the value of 1 upon z minus 2 dz equals to 0, since z equals to 2 lies outside C, as we checked previously. Okay, so now for the remaining part, that is 2 integration along 1 by z dz minus 1 upon z minus 1 dz, it is C. Okay, so what you need to do, we apply the Cauchy's integral formula to evaluate that one. Okay, so what is the Cauchy's integral formula? We write here, that is, we know f of a equals to what? 1 upon 2 pi iota integration along C f of z, and in the denominator it is z minus a to the power dz. Okay, or we can write it 2 pi iota f of a equals to integration along C f of z, and in the denominator it is z minus a dz. Okay, so value of integral. So here we are having, this implies it is what? 2 pi iota f of a. So I write over here 2 pi iota, and in the bracket we are solving that one. Okay, that part. So first integral is 2. So 2, and in the bracket it is, let this will be curly bracket, and in the bracket it is what? If we see that here it is 1 upon z, that is, we can write it z, that is the point is 0. 1 upon z, that is the point is 0. So f of e, that is f of 0. Okay, minus, for that point, for that integral, the point is z minus 1 equal to 0, that is z equals to 1, that is a equals to 1. So here it is f of 1. Okay, so simply it is, what we need to do, we find the value of f of z at at a equal to 0 and a equals to 1. Okay, so since f of z is, if we see that integral, okay, if we see that integral, so when we compare this one, suppose if f of z is what? 1. Why? Since it is f of z upon z minus a dz, and we are having integral 1 upon z minus 1 upon z dz. So here when we compare, so f of z is 1. Okay, f of z is 1. Similarly, for second term, if we see second term again, since we compare it with again, so here it is 1 upon z minus 1 dz. So when we compare this one with this, again we have f of z equals to 1, that in both, for both the term f of z is 1. So f of z is 1, then f of z is 1, this implies f of 0 is also 1 and f of 1 is also 1. Okay, so the integral, which is 4 minus 3z upon z, z minus 1, z minus 2 along C, is equals to what? Is equals to 2 pi iota 2 f of 0 and minus f of 1. Okay, 2 f of 0 and 2 f of 1. So just simply put the value of f of 0 minus f of 1, which is both 2 pi iota. It is 2 minus 1. So it is 2 pi iota will be answer. Okay. So first we separate it by using partial fraction and apply the Cauchy's integral formula to evaluate the given integral. Okay, and the point which lies outside that curve, so according to Cauchy's integral theorem, the value of that integral will be 0. Okay, so thank you for today's lecture, and here are the some reference book you can use for more. Thank you.